Today's lesson is the start of Chapter 7. It's going to be our last chapter. And this is Lesson 1, but it comes from Section 7.2 in your book. What I'm going to do is we're going to work on some solving first, and then we're going to come back and look at Section 7.1, which is more about what is a system and things like that. So, what we're doing today is we're solving systems of equations graphically. And the learning intentions, what you're expected to understand by the end of this, is first, to be able to solve a system of linear equations by graphing the two lines. So chapter 6, we graphed lines over and over, and now we're going to use those graphs to solve a system. And the second one is to be able to check your solutions, so the solutions you get from part 1, from learning intention number 1, using algebra. So you should be able to solve it and then check your work. So here's our first set of questions, and it is just solve the linear system. And this one's nice because it's already drawn the lines on for us. In the future, what you're going to have to do is you're going to have to first maybe come up with the line equations, then graph lines, and then solve it. So at the base of it, though, solving the linear system. First of all, a system just means there's more than one. So there are two lines. So it's a linear, meaning straight lines, no curves. So linear straight lines, system more than one. Solving it is where these lines meet each other. That's as simple as it is. So where do these lines meet? That's happening right here. So solving this linear system, it is on x, it's over 1. On y, it's down -1. So solving this linear system, it is the coordinate 1, -1. X is 1, y is -1. And we've solved this linear system. So again, a system means there's more than one line. Linear means there are straight lines. Solving it is where does it meet both lines. Up here, it's not on both lines. Down here, not on both lines. Solving it is where it meets both. Right here, the point 1, -1. So here's a more typical question. We're going to solve this linear system. It's a linear system because we have two lines. So first, I'll do the first one in black. Y equals 2x minus 3. This is in the form y equals mx plus b. So what we know is b is our starting point. It's the intercept. Our y-intercept is -3. The part with the x is a slope. So our rise over run is 2. So we're going up 2 over 1. Up 2 over 1, up 2 over 1, up 2 over 1. And if you want now, you can connect those. There's our line. Now for the next one, I'm going to use a red line. So for this one, y equals mx plus b. B's our intercept, so at 4. 1, 2, 3, 4. Our slope, our rise over our run, is going down 1 over 3. Down 1 over 3. Down 1 over 3, and it continues. And I'll put this line on there, like this. So we've graphed both lines. To solve by graphing, you need to graph. So I've graphed the lines. So now to solve it, solving is where they meet each other. These are meeting right here, which is the coordinate over 3, up 3. So x is 3, y is 3. So, for example, this coordinate didn't solve it. It solved one of the points on this line, but it did not meet the requirements of this line. So let's look at learning intention number 2 now, which was checking your work. So to check it, this coordinate xy would need to satisfy both lines. It's saying this coordinate is on the black line. This coordinate is on the red line. So when we plug them into the equation x and y, it should check for both. So let's try that now. We'll try the first one. Y equals 2x minus 3. X is 3, y is 3. So my y is 3, my x is 3, and I get 3. 2 times 3 is 6. 3 equals 3. That is a true statement, so it checks. So what I know is I know that 3, 3 is in fact on the black line with my algebraic check. Now let's check if it meets this line's criteria. So x is 3, y is 3. Okay. Negative 1 times 3 is negative 3. Divide by 3 is negative 1. Negative 1 plus 4 is 3. 3 equals 3. It's a true statement, so it checked. So when I put my answer into both lines, it solved both lines. It gave me true statements. That is how I know it is a solution. If, let's say, I had tried a different point. Let's say I had tried this coordinate here, which is the coordinate 6, 2. Now, I know that's going to be a solution for the red line, but it won't be a solution for the black line. And I'm going to show that to you here. So let's see if 6, 2 would have worked. So if I tried my first one, y equals 2x minus 3, x, y. So my x is 6, my y is 2. So I get 2 equals 12 minus 3. Does 2 equal 9? No, so it doesn't work. It would need to work for both equations. It would work for the red one. We can do that really quick here. We'll put the 6 into there and the 2 in for the y. So 2 equals negative 2 plus 4. 2 equals 2. Yes, it does. So it did check for the red line because it is part of that line. But it did not check for the black line, so it did not solve both equations where they meet. Let's look at another example. For this one, solve this system. We have two lines here. And the problem is this is no longer in y equals mx plus b form, and that's our most preferred way to graph. So there are a couple ways to do this, though. You could find the intercepts of this line and graph it that way. So maybe that's what I'll do. I'll do intercepts for one, and the other one I'll put in y equals form. So the first one, x plus y equals 5. To graph it, I am going to put it in y equals form. So that just means get the y alone. To get this y alone, right now it's being added by x, so I need to subtract x from both sides. And I get y equals negative x plus 5. That is now in y equals mx plus b form. My intercept is 5. My slope is negative 1. So slope is negative 1. Intercept is 5. And that's something I can graph easily. My intercept is at 5. My intercept is negative 1, so it's going down 1 over 1, down 1 over 1. I'm going to connect those up now. Now the other one, x minus y equals 1. I could solve that the same way, or graph it the same way. I could get the y alone and then graph. But I want to show you another way, just in case you're not loving the y equals mx plus b method. Another way to solve this would be to find the intercepts. And the intercepts are where it touches the axis. One way is to find where x equals 0. The other is to find where y equals 0. So for this, let's find where x equals 0. Put a 0 in the x's spot. So 0 minus y equals 1. So negative y equals 1. I want y, so I'm going to times both by negative 1, and I get y equals negative 1. So 0 is x, y is negative 1. So 0, negative 1 is a point on my graph. Now the next one, let's find where y equals 0. So where y equals 0, I'm going to put a 0 in y's spot. So I get x minus 0 equals 1. X minus 0 is just x, so x equals 1. So x equals 1 is my x-intercept. Sorry. Yes, my x-intercept. So now, once you've found your two intercepts, because this one is just the coordinate x is 1, y is 0. So 1, 0, and 0, negative 1. Any 2 points will give you the rest of the line, which I'll do now. So it's going like this. So I graphed the one using y equals mx plus b. I graphed the second one by finding my two Intercepts. Where does x equal 0? Where does y equal 0? When I found those two coordinates, I connected them. Now what is my answer? My answer is the point that meets both of these lines. And that's occurring at the coordinate 3, 2. Okay, so x is 3, y is 2. And now we can do a check. So to do a check, I'm just going to erase this part here. X is 3, y is 2. It needs to meet both lines if it's an answer. So let's try the first one. X plus y equals 5. X is 3, y is 2. Does 5 equal 5? Yes, it does. And now the next one. X minus y equals 1. X is 3, y is 2. Does 1 equal 1? It does. So because 3, 2 makes both of these true statements, this is, in fact, an answer to my solution. Your assignment today for this section is page 409, questions 3 to 7. Do all the letters for 3 to 7. And this will just be simply take the equation and graph it. And then later on, like I said, we're going to get into some of the problem solving and creating our own systems. Good luck. Stay classy, math class.